Hi, my name is Elina Moon, and I am in the Chem 182 lab section on Thursdays from 4:30 to 6:50, and I'm going to be doing my Postlab video number 1 for the crystallization of alum crystals lab. So, crystallization is a physical change that forms large crystals in their pure state from their liquid solutions. So basically, the principle behind this idea is that increasing the temperature of a solution will also increase its solubility, or the amount of solute it's able to dissolve. So over the course of about 3 weeks, I'll be documenting the size and growth of the alum crystals that we created in class. And currently, the first file, I will be evaluating the growth and the size of it in this next clip right here. So right now it is January 22nd, 2019, and I am going to track the progress of the vials for right now. And the vial was made on Thursday, January 17th, 2019 at 6:34 p.m. And if you can tell by the drawing, there's little tiny crystals that I drew because right now, not exactly sure if it's visible, but on the bottom you can see small crystals, and there's maybe, I want to say, a little bit on either side. They look like teeny tiny grains of, I wouldn't say like normal table salt, but I would say the thicker salt that you can sprinkle on maybe like meats. There's not that many. It hasn't grown too much. They look like little pebbles of sand. But as for week 1, there's not much growing yet in the vials. And here is a better look at the little crystals in the vial. As you can see, they're very small, and they're in the corners of the vial, not built up too much yet, and not that many. And now we're going to move on to the process of the chemistry of the crystallization that is currently happening right now. So basically, the alum crystals originated from solid aluminum foil. So in the first reaction, we have aluminum and the KOH base, and so they both reacted to form these two products. Because the KOH is a base, it can dissolve with the solid aluminum to form AlOH4- ions, which we'll see in the next reaction. Now, after filtrating out the impurities from the last solution, we were left with the liquid portion of the solution, which had the AlOH4 ions, which then we added to the sulfuric acid, as you can see in this following equation. Adding the acid to the ions creates the solid aluminum hydroxide precipitate, which we'll see in the next reaction. But meanwhile, the additional hydrosulfuric acid and the AlOH3 solid formed these two products. Other than creating just a saturated solution, there is another way I could experiment with to grow a crystal, which is called nucleation. And nucleation either spontaneously occurs or it can be induced by vibration of particles. So the formation of nuclei will reduce the concentration of ions. So to grow the best crystals, the solution must be at a concentration of oversaturation in which nuclei does not form anymore. This is the separation of new crystals, so in order to keep it at this point, the system must be slow. However, because that process is a little bit more difficult, another process of crystallization that we can use is actually used to make rock candy from sugar crystals. So basically in this process, you can dip a wooden skewer or thin stick into water and then dip it into sugar, and that'll create a base for the crystals to form. So you keep the sugar-coated stick and put it in the boiled and supersaturated sugar solution. So we have this pot that we will boil with water and sugar, which is the supersaturated solution. And basically, you you can pour that into like a little beaker or a vial or anything like that, then stick the previously sugar-coated stick into the oversaturated solution, and within about a few days, the sugar crystals will begin to form on the stick. And because increasing the temperature of the water also increases the solubility, we are able to create the supersaturated solution. And as the temperature drops back down, the molecules will release the sugars and attach to each other to form the sugar precipitate. So looking more into the temperature aspect of where the experiment or the vials are going to be in, for example, if this is the original solution, if the reaction is done under a hot temperature, then it's very quick. So basically, the water in the solution evaporates too quickly. There's going to be more crystals, just not as many. However, if the water evaporates slowly in a more cold temperature environment, then the crystal ions and the impurities will bond to form bigger, more uniform crystals. But however, if the same solution is grown in warmer temperatures compared to colder temperatures, the solution in warmer temperatures tend to grow faster, and also since evaporation is expedited, this is why the saturated salt solution mentioned previously was boiled. Now, instead of alum crystals, if we wanted to grow salt crystals, we could basically use a similar process and create a saturated solution of water and salt. So I would need to make sure that I added enough salt to the solution so that the solution was saturated. So I would basically boil the water and add salt to the point until no more salt can dissolve. And then we can boil the solution to help it dissolve and expedite the process. But if you just leave the solution, then it'll slowly evaporate, same process as before, and then it'll basically create little salt crystals. Now, there are several factors that do control crystal growth. Some of them include pressure, amount of material dissolved, evaporation, and temperature. And we're gonna look more into the temperature aspect. So as mentioned before in the last reaction, we added the acid, the sulfuric acid, to the ions in order to create this precipitate right here. In the procedure, we added the ice bath to the solution in order to create this precipitate. And so why does this acid cause a precipitate to form? It's due to simple precipitation chemistry. So we have the Al ions, the OH ions, the SO4-2 ions, and then the K+ ions. Now A, B, and D are going to form the solid, and then the OH and the K are basically just going to kind of float out of the solution, and that's how we get this precipitate. In the procedure, the product was again filtrated in order to ensure that it was free of impurities, and the pure alum product that we finally got was mixed with water, and we basically filtered it into the small little vials that we got in order to create the saturated solution. So basically, over time, as the water will slowly evaporate, the Al- ions that we see, the blue parts right here, they'll basically find each other and join and form crystals over here. So as the impurities are evaporating, these find each other, the Al ions, and to form the crystals. So the joining of the mineral atoms creates recurring patterns that form the hard, strong crystals, which is called the process of crystallization.